Now let's get started talking a little bit about what the National Research Platform is. So the incentive behind the National Research Platform is towards tackling a bunch of challenges that we've noticed, including and are hoping we can address with NRP, mainly the rising demand for cyber infrastructure resources, both for research and education. So there is a growing reliance on CI, so cyber infrastructure resources in general, and there is a gap that is growing larger and larger between what institutes have CI resources, what institutes don't have CI resources, what professors or PIs or labs or students have access to these resources, and between who does and who doesn't. And there is a little bit of a gap as well in the era where we're past Moore's law now, where we live in an era post Moore's law, where computational requirements and hardware resources in general uh, are not basically what they used to be. We're in a new era where we have new architectures, new types of cards, new types of hardware resources. It's not the classic definition of HPC, for example, where it's just compute power and CPU cores and memory. We have new architectures. This is more visible now in the age of AI and ML, where we have all sorts of new hardware technologies. And this creates sort of a gap between the domain scientist and the domain researcher who wants to use these hardware resources, but there's all kinds of complexities between gaining access to the hardware or having the hardware and setting the hardware up and understanding the domain of the hardware and how to provision it, how to use it, and sometimes it's nearly impossible to get to a working use case for certain hardware technologies and hardware architectures where a domain scientist can get a reproducible success where they can build on top of it with their domain research. So that's what we're hoping to tackle with the National Research Platform in providing one nationwide and even internationally spanning platform, both for research and education, where we as operators of the cluster and of the platform aim to provide everyone on the cluster with easy to follow, easily accessible, generally available. What we mean by generally available is that users can request the resources and do their work on them without added complications and complexities in provisioning those resources to sort of bridge the gap between institutes, between individuals, the disparity in gaining access to CI resources. And with our eyes on the future, hoping that we can prioritize CI access for all institutions, for everybody, and connect educational institutions, because as a byproduct of having the platform, we're also fostering a community of both research and education. And that in its part also empowers talent and pushes forward research across NRP in general and drives more investment in CI in general and competitiveness in CI as well. And now what that basically manifests into what the National Research Platform is. In its current state, currently it's a partnership of more than 70 institutes that have provided hardware and resources to the NRP. And it's primarily led by us as daily operations and teams. We're researchers at the University of California at San Diego and the San Diego Supercomputer Center, the University of Nebraska at Lincoln, and the Massachusetts Green High Performance Computing Center, MGHPCC. Of course, it includes various contributions by the NSF, DOE, DOD, and many, many research universities, research labs, and organizations across the United States and crossing continental borders to grow internationally. And what NRP is, in technical terms, it's basically a one giant Kubernetes cluster with hardware spanning across sites. So everything under the National Research Platform basically runs in one Kubernetes cluster. And here you can see this is a live dashboard. This screenshot is from this morning, and you can actually visit this live dashboard and interact with it at dash.nrp-nautilus.io. We've included the link at the bottom. And you can see various sites. Of course, this map is zoomed in at the US, but you can zoom out. You can see some international locations. You can see the National Research Platform is closing on 30,000 CPU cores now, closing on 1,500 GPUs, closing on 440 nodes, and 48 sites now. So the even the 70 plus figure is growing larger and larger, and the cluster is actively growing. You can see here, these are the three main sites where we deal with operations. And the National Research Platform itself has, in its topology, is incorporated into the Internet 2 and both the Internet 2 and ESNet backbones. And it incorporates various resources between GPUs, FPGAs, different compute resources, GigaIO HPC fabric that allows for composing hardware, and we have basically distributed storage classes and data transfer nodes, and we are open to including more and more sites because, as we like to call it, the National Research Platform operates on what we call the potluck model, where we have initiatives for bringing your own resources and bringing your own hardware, where you can just plug in your hardware resources, and we'll deal with all the operations. We'll provision them. We'll add them as actual nodes on the Kubernetes cluster. And of course, all of that is documented in our documentation on how users can join in their hardware, what is needed from the hardware side, what is needed from the network side as well. And of course, like we said, it's eventually one Kubernetes cluster. And for those who are joining NRP and they're not familiar with the Kubernetes, or this is their first experience with Kubernetes and with any HPC system, any distributed computing in general, we aim to provide in our documentation easy to use, easily reproducible guides and examples so anyone can get started with the cluster. And we even have access points where users can use the cluster without any Kubernetes knowledge, and we'll talk about that a little bit later. But generally, just to give you a brief overview, so in Kubernetes, we have the control plane. So those are the nodes that manage the cluster, and the worker nodes. And we have the worker nodes that are running the pods, that are running the experiments. So those are the worker nodes that are actually running the workflows from users and services. And this cluster, the Nautilus cluster, has been in continuous operation for more than 6 years now. Uh, what first started as the Pacific Research Platform has grown into the National Research Platform, and it's even growing internationally now. And it provides various services between various storage options like the Ceph file system, the CERN VM file system, S3 buckets. And of course, we're going to talk about storage options in different sessions more in detail, to advanced monitoring tools like PerfSonar, Traceroute. And we have a very high focus on measuring and monitoring between collecting data on Prometheus, dashboarding it on Grafana, using SFlow and different network monitoring tools. And we have a very high focus on data collection and metrics in general. And the cluster also provides software resources for the user that everybody can use and make use of, including JupyterHub that is available for all cluster users, GitLab, which allows for also running DevOps and pipelines and building Docker images inside of the cluster. So we have a self-hosted NRP GitLab. We have Nextcloud, which is a cloud file sharing tool, very similar to for those of you that use Google Drive and OneDrive. Nextcloud is very similar to that. We have also our self-hosted Overleaf for LaTeX and scientific writing. And we have, for example, we have different software, whatever software that we deploy and we find useful for the general public, we deploy for everybody with federated access. So WebODM, for example, is open source software that displays Gaussian splatting and 3D rendering environments. So that is as well one of the things that are incorporated into the cluster. Jitsi, for example, is also a free Zoom alternative that does video conferencing, and we host it on the cluster. And we'll also get more in detail about the services that are hosted on the cluster. And like we said, the cluster is growing in hardware resources on top of the GPUs and CPU cores and memory. We have plenty of FPGAs. We're growing our FPGA models. We have plenty of DPUs and SmartNICs and smart SSDs and different network components as well that are also, not only are they deployment hardware for running the nodes themselves, but they're also research resources that researchers can use and use them for their own sort of testbed experiments. And for more on hardware on the Nautilus cluster, we have some ARM nodes, we have x86 64 nodes, we have Intel nodes, we have AMD nodes. We have very, very diverse GPU types between going from GTX and RTX cards, so 4090s, 3090s, and and what are basically called gaming GPUs. We have almost 600 of those RTX GTX cards, and we have various data center card models as well between H200, A100. These are all NVIDIA model GPUs. Uh, A6000s, A10s, A40s, and so on. And we're also focusing more on new novel compute architectures. One example would be the Qualcomm Cloud AI 100 Ultra inference cards. So those are basically TPUs, they're tensor processing units. And just to answer everybody in Q&A, the recording will be posted for every single session, and they will be posted on the website and announced as well. So those inference cards, basically they're PCI cards that are systems on chips. So each card consists of four individual devices. So for example, we have eight devices, that is 32, eight cards, that's 32 devices in total, and they're completely modular. So each individual device can host inference models, LLMs, for example, with out-of-the-box configurations where they can be easily pulled from Hugging Face, and they're provisioned through Kubernetes, and you can combine any multiple of one of these devices for larger models. And of course, in our documentation, and you can visit our documentation on docs.nrp.ai, we give you an overview of what hardware resources are available generally in one node, because one point to it is being aware of what the cluster has to offer. So you know how to provision your workflows in a more efficient fashion. So for example, if you go into provision 5 FPGAs, you will need to start more than one pod because the maximum number of FPGAs in a node is four, for example. And that sort of hardware aware provisioning we try to provide it as easily as possible in our documentation. But if you want to look at what hardware resources are available in visualizations and dashboards and notebooks, you can visit nrp.ai/viz. This is where we keep all the links for visualizations in general. /resources shows you every single node on the cluster, and in columns you can see what resources it has to offer and what characteristics it has. For example, what zone it's in, what kind of GPU it hosts, and so on. And just briefly, like we mentioned, we have multiple networking components as well, including ConnectX network interface cards, ConnectX 6 and ConnectX 5 and 7. Those are hardware resources as well that are provisionable through Kubernetes and are usable for network experiments and before switches, before programmable FPGAs. So the Xilinx Alveo U55Cs, those aside from being fully programmable, the RTL code and HLS code, they're also fully programmable before SmartNICs, as well as the Stratix FPGAs and other FPGA models. They're fully programmable as SmartNICs as well. And we have NVIDIA Bluefield DPUs as well, and smart SSDs. Those are SSDs with the FPGA chips that make them fully programmable near compute storage. And the cluster does support multiple operators and multiple tools that enable researchers to conduct all kinds of experiments they would like, including constructing network topologies and L2 paths. And of course, the cluster also has various storage options on it for persistent storage, because in Kubernetes, in general, Kubernetes pods have an ephemeral nature because they essentially run containers. So we provide different nodes spin up different storage pools for persistent storage the users and the groups can use and host their data sets or their files on. And the main one being the Ceph file system, so the Cephfs. And this, of course, provides read-write many volumes. So read-write many volumes means the same volume can be mounted to different pods running on different physical servers, so physical hosts, or what in Kubernetes terms, Kubernetes nodes. So nodes in Kubernetes are the actual servers. And the other one is Ceph RBD, so the Rados block device. This is a different file system for creating read-write only volumes. So those are volumes that can be mounted to one node at a time, to one server at a time. So you can think of it as one pod or one container at a time. And of course we have different file systems. So LinStore is also read-write many. It's significantly faster than Cephfs, for example. We have S3 storage. Of course, that is not mounted. You can use bucket tools like AWS, the AWS command line tool, and different command line tools and Python libraries for interacting with S3. One thing to note here for a lot of users, so we host our own S3 storage where you can create your own S3 buckets on NRP. This is completely separate from Amazon. This is not on AWS. It's just using the same file system. And of course, we host the Open Science Data Federation and the Open Science Grid on the National Research Platform, which also hosts data origins and file storage on the Nautilus cluster as well. And for these storage options, we'll go further in detail on how to provision them, how to use them in later sessions, mainly the beginner Docker and Kubernetes session and the intermediate one will show you in detail how to provision all sorts of storage for whatever use case you have. And the other thing to mention here is how to request user support. So this is one main part of using NRP. So ideally, every single NRP user would be on our Matrix server. We host our own Matrix server. So Matrix is a chat server service where any user can use their CI logon and create accounts and you join our Matrix chat. And you can see here in the screenshot, so you have rooms and those are chat rooms. Some of them are public rooms like Nautilus support is the one main room every single user should be in and is joined to by default, where you can ask for user support. So we have our operations team. If you email us directly, it will receive your email. Uh, if every single user does that, it'll eventually build a backlog, and who knows when we'll be able to actually get to you in real time. But if you're sending your support request in Nautilus support, that is the official way of requesting support. Because right now, when you post it, you're in a chat room basically. So you gain access to all of our operations team. So if whoever sees your message will answer you, will help you, and you gain access to the community because we've seen many cases where having this knowledge support channel room, sorry, and all the other rooms uh, builds a very helpful community because you might be asking a very specific question that someone else has ran into and they'll be able to help you, and it'll be the other way around. You'll run into cases where you've run into something and you can help someone else run it. And of course, the other channel is NRP News. NRP News is also equally as important as Nautilus support. You should be up on both because NRP News is the main channel, main room where we post real-time cluster news. So any new features, any new things that we implement, any maintenance outages and real-time news that affect users and are highly relevant to users, they go directly in NRP News. And that's where we announce training sessions, included and office hours and so on and so forth. And of course, to be able to join our Matrix server, all the information you need is at https forward slash nrp.ai forward slash contact. So nrp.ai, that's the main NRP website. The contact page gives you detailed step by step how to join the Matrix server. And of course, you need a client and you don't need to download anything or install anything. So Element is a Matrix chat client. It's not developed or maintained by us. We just provide it. We link to it if you want to install a local client because it's cross-platform. They have a client for Mac, Linux, Windows, Android, iOS, so on. And you can either use the client or you can use our web hosted version and not install anything. So we host it at element.nrp-nautilus.io, and you can also find this link here at the contact page. So all the information you need on joining the community, you'll see on our contact page. And I see a question, are sensitive data supported by NRP? So data that have persistent identifiers. So we generally recommend that for NRP, any sensitive data, any data that is subject to any sort of regulation or, for example, HIPAA compliance and whatnot, we ask you to not host it on NRP because we cannot guarantee the data sensitivity and security. So In general, if you have data sensitive, anything regulated, please do not host it on NRP. But to do ask us, we can always discuss different options. We can coordinate together. But in general, don't go hosting any data in any persistent volumes without talking to us first. And I see another question. Will the slides be uploaded? Yeah, the slides will be uploaded. But the cool thing about documentation, if you go to docs.nrp.ai, if you visit documentation, you should have everything you need without even needing the slides. But the slides will be uploaded, yes. And you'll see them on the training webpage and announced on Matrix as well. And are we supposed to apply for an NRP account or do we get access through our access credentials? So NRP currently is not NRP is not an access system yet. We're joining access resources a year from now, but right now it's not an NSF access system. You don't request allocations. You the way you join, and this will go through this step by step in the other session starting at 11. But you join from logging into the website and joining Matrix. And if you're a PI or a professor or faculty, you reach out to us on Matrix and we set you up with the access, and then you can add your students, for example. Of course, we'll discuss more about the process later, but you can try it right now while we're on in the slides. You can log into nrp.ai and ping us on Matrix. And uh, like like similar cases, the documentation also gives you step by step, and we'll go over these steps together. But the main takeaway here is please be on Matrix because that's the fastest, easiest way to get support and to stay up to date with cluster news. And now to just talk a little bit about how to gain access to knowledge and how to use NRP in general. So in general, to simplify it, we say there's three main access points to NRP to actually using the cluster. So making use of the resources that we talked about, which are JupyterHub, Coder, and Kubernetes. And of course, since Nautilus itself is a Kubernetes cluster, so you gain access to Kubernetes, you have, let me call it the lowest level of access where you can deploy your own services. So if you gain access to Kubernetes, virtually you can deploy your own Jupyter, you can deploy your own Coder, and you have more mobility, more autonomy to deploy more services. JupyterHub and Coder both are web interfaces, web services that allow you to use the cluster resources without having to deal with Kubernetes or interact with Kubernetes. And you can see here, for example, JupyterHub, we host public instances of JupyterHub. So there's jupyterhub-west.nrp-nautilus.io and jupyterhub-east.nrp-nautilus.io. Those are two different instances of JupyterHub that we host, we maintain. So the admins of these hubs are basically us, the operations team. And you can log into these instances with your CI logon. And like you can see here in the interface, you have pickers for different hardware resources. So you can choose the region you're landing in physically, geographically, how many GPUs, how many CPU cores, memory, and so on. And you'll get started with a container that is running Jupyter. So you can have Jupyter notebooks, you can have Jupyter Lab in general, and you can run your requesting resources without having to interact with Kubernetes whatsoever. But one small thing to mention here is that you need to be part of a namespace or a group, and we'll talk about that a little bit later down the road. But you'll need to be part of a group that is authenticated and documented within NRP to be able to access JupyterHub itself. And you can see JupyterHub, we provide various images, so images that have libraries for R and SciPy and Julia, TensorFlow, PyTorch, and so on. And those are official Jupyter Docker images. We also provide our own stack that we've built in-house. Where we provide different libraries that are tested and verified with the cluster. So, for example, our NRP images. Sorry, I skipped a slide. So our NRP images, if you request PyTorch and you've requested GPUs, you get a PyTorch container that has all the tools that you need, in compliance with the CUDA versions that we use, the driver versions that we use, and so on and so forth. We have different images. Sulky's desktop is a GUI desktop environment inside of JupyterHub, and NRP desktop GUI also is another no VNC desktop environment inside of JupyterHub. So with these ones, you'll see in your Jupyter Lab desktop launchers that launch you into a full GUI Linux desktop environment. And of course, we'll talk more in detail in the session about JupyterHub encoder as well. One thing to note here is that our main recommendation for classrooms that want to be taught on NRP is to spin up your own JupyterHub environment. So uh, the easiest way for students to gain access to NRP and use NRP is through JupyterHub, because you use CI logon, you're in, you click buttons, and you are started in your instance. And that's a highly adopted way of accessing NRP that is on Nautilus. And we have thousands of users from different institutes that are purely JupyterHub users. We have hundreds of namespaces with their own JupyterHub instances that are very similar to ours and highly customizable. So when you're spinning up your own JupyterHub environment, you have more mobility to do customization. So you can, for example, start a volume that has a data set and make Jupyter by default mount it as, for example, read-only to every instance that starts. This way, for example, if you host a data set, every one of your students will gain access to that data set by default without having to go through any steps. And this is, of course, all part of NRP's focus on education, and NRP's being part of the NAIR pilot program, so the NSF NAIR pilot program. If you get NSF NAIR allocations on NRP, you can teach classes on NRP. Of course, if you can also teach classes without the NAIR allocation. And like we mentioned, we're available on Matrix to help you set up your own JupyterHub environment and customize it, and tell you how to give access to your students, but not general public access, and so on and so forth. And of course, all of this is documented in our documentation. And we have various NAIR classroom allocations that are currently running, and classes and that are currently running on NRP. And we actually have more and more classes being taught this fall as we start the semester. And the other service here, other than JupyterHub, is Coder. So Coder, for those of you who are not familiar, it's also a web service. So it's hosted on coder.nrp-nautilus.io. And like JupyterHub, you need to be affiliated or part of a namespace or a group on NRP. And we'll talk about how to get to that point later on. But you can access Coder, and you can see that we host our own Coder instance. But we also provide you, like JupyterHub, we provide you with documentations on how to spin up your own instance that suits your use cases. And of course, users log in with CI logon, very similar to JupyterHub, and we provide multiple templates. So multiple, let me call them recipes or flavors on how to use Coder. And of course, you can see here, I don't know if it's small on your screen, but you can see the templates. We provide multiple templates. So in coder terminology, a template is what we call let me call it recipe, and you click on it to start a workspace. So your workspace is the workflow that you start, and we give you different the pre-built templates, like a CUDA, PyTorch, TensorFlow template, for example, is a template that starts PyTorch and TensorFlow in one Docker container where you can request GPUs. It automatically, like JupyterHub, also has persistent storage mounted to your home directory, and we have different templates for Node.js, Jupyter as well. Dev containers. Dev containers is where you basically develop, but you have a development container. So you basically have a Docker file and you're running your development in a standalone container. And when you start dev containers, you just give it, for example, the link of your repo, and it builds your Docker container for you, and so on. And of course, we'll get more into detail in the Coder and Jupyter session about how to use Coder. But one incentive for using coders that we have is using it for FPGAs, because it makes provisioning FPGAs easier, because like you see, we have multiple templates for FPGAs where since templates offer a lot of mobility, we can customize them however we want. So FPGAs, there's customizable programmable hardware. They have their own software tools. They have their own licensing servers for their software tools. They have their own hardware requests, their own Hardware requirements, for example, they require different kernel parameters. They require different hardware resources from the huge pages, for example, different tools and hardware configurations for them to run their workflows correctly. So telling users to provision all of that with YAML is too complex of a recipe. Meanwhile, with Coder, it's a GUI. You click on the template, you start your workflow or your workspace, and this is basically what you see. This is, here's the pointer. So this is what you see when you start a workflow. You have a VS Code desktop, let me call it plugin, and that's one main incentive to use Coder is that it authenticates into your local VS Code desktop that you've customized, you've installed extensions, you're comfortable with using. It automatically connects your workspace that you started on the cluster with your local VS Code. And on top of that, it also deploys a web-based VS Code, so a VS Code server, which is basically VS Code in a browser window. So you have an IDE that is launching from the container itself, and also terminal in a window, and no VNC desktop environment. So for any applications that use GUI, it's just one click of a button and you have your desktop environment. And of course, Coder also has two handy features. It has an SSH key that is, of course, a private SSH key that every single user gets their own SSH key that even us as admins we can't access. That is populated into every workspace the user starts. So you can take that key, for example, and add it to, let's say, GitHub, and then whatever workspace you're developing in, you can push to GitHub from without having to reconfigure keys or re-authenticate every single time. And the other thing is that Coder itself, as a platform, has a command line tool that you install locally. You can, for example, SSH into your pods with one command. So Coder SSH workspace name, and you're in. And of course, another incentive here is that Coder uses Terraform, and Terraform is a HashiCorp configuration language, which is, you can see an example of how that looks like here. And you can see it does not use YAML. This is what Terraform looks like. You can see here, this is one example. So I can specify complicated things that are not easily feasible in YAML using Coder. So when I host my own Coder instance, I can in Terraform, for example, use public providers. So in Terraform terminology, they're called providers, and Coder provides various modules and providers where I can just pull them by calling them resource. For example, Coder app, RStudio. So there are Coder apps, one of them is RStudio, and I just add this block of code, and now whatever pod I start, it has RStudio installed in it, and I have a GUI button that starts RStudio. Different examples that are also they're ready to add code blocks that you just add them to your template and they're part of your workflow. For example, there are many ones. There's one called Slack Me that basically whatever your workspace is running, once it's done, it DMs you on Slack. So you get a notification that it's done. There's a Tmux for whoever uses Tmux with their workspaces. They don't have to configure Tmux with different OSs. They just add the code block and that's it. And you can see since it uses Terraform, not specifically Kubernetes YAML, you can use different providers and do the very different complicated things. So in Terraform, for example, you can launch AWS instances and you can launch Kubernetes pods in NRP. And you can use one Terraform to do both as well. So basically, it's a blank canvas where you have a lot of space to specify your workflows however you want. One example of that is that we start pods and the volumes as well for having persistent storage for users in Coder. And we'll go over that in more detail in later sessions. But that covers JupyterHub and Coder, the main two ways of using the cluster without having to learn Kubernetes. But it still remains that NRP is one Kubernetes cluster called Nautilus, and if you gain access to Kubernetes, you have more room to do more complicated and more elaborate workflows. And of course, the main way to access Kubernetes is through the Kubernetes API, which you talk to using a command line tool that you install locally that is called kubectl or kubectl. And we're going to be going next week over kubectl and how to use it in detail and how to start pods and containers and volumes and whatever we want to do with on the cluster with kubectl. But basically, you define manifests or recipes or whatever you want to call them for your where you're starting in either YAML or JSON files, and you use kubectl to apply those in your namespace, which is you can think of it as the scope where you run your workflows, so the group you're part of. And just a brief overview of Kubernetes. In Kubernetes, you'll run the term pod, you run across the term pod a lot, and you'll have to know what a pod is. So a pod is the smallest deployable unit in Kubernetes. It's the smallest uh, unit of running containers in Kubernetes. So a pod is basically the arbitrary object that hosts one or more containers and requests resources. So you can think of it in the beginning phases, you can sort of equate pod and container, even though a pod can run multiple containers, but you'll be starting pods to run workflows. And every single workflow that you run in Kubernetes eventually runs pods, and that's how it runs. So batch jobs, for example, are when you submit essentially bulk pods that do their tasks in a scripted fashion, an HPC-like fashion, and then terminate. Those jobs, when you request jobs, how they manifest into the actually running the workflows is that they run pods. Deployments as well for long-running services and persistent services, when you run deployments, the way your deployments run is through pods. And we have different Kubernetes terms and objects and resource definitions, like replica sets, daemon sets, cron jobs, and replication controllers and operators and so on that we'll be getting into more with the more Kubernetes sessions. But uh, for now, all you need to know is that pods are the smallest unit that you run in, and everything runs in pods. And pods run in your namespace. So namespaces, you can think of them as scopes. They're where you run your workflows. So your namespace is the group in Kubernetes that you're part of, and you can be part of multiple namespaces. But you can run pods in different namespaces and request resources in namespaces because most resources that you see in Kubernetes that you run across are namespace scoped. So when you run pods or volumes or whatnot, persistent volume claims, they're all running in your namespace scope. And you'll see the resources that are cluster scoped. So those are resources that are persistent across constant and across the cluster, not a namespace. So for nodes, for example, like we mentioned, nodes in Kubernetes are the actual servers. So actual racks, actual computers, and they're represented in Kubernetes as Kubernetes nodes. And nodes are not specific to namespaces; they're cluster scoped. And you'll come across the term RBAC or role-based access control a lot, which is in Kubernetes, basically that's the definition of who can do what and where. And of course, how that manifests in NRP is that you have guests who basically can't do anything because they're not users yet, users who are part of namespaces, and you have namespace admins. So namespace admins, basically that's the role normally reserved for instructors, PIs, lab supervisors, and so on. Lab namespace admins have more control over their namespace and what they can access in it. Users have the normal users privilege, and of course we have the cluster admins, the operations team that handles the daily operations of the cluster. And similar to pods, deployments, jobs, you have persistent volumes and persistent volume claims, which is the main way you request storage. Like we mentioned, different storage types in on NRP and on Nautilus, and you request those through persistent volume claims. So that's the name of the object. And if you want to learn more, so you'll see in our documentation, so nrp.ai/documentation or docs.nrp.ai, both lead to the same link. You'll see our storage documentation in detail. But just to give you a very brief example of how to provision volumes and pods that are, for example, running BusyBox or Ubuntu in Kubernetes, this is just giving you a very brief example, and it's okay if you don't understand how to apply this or haven't seen this before. It's okay if this feels super easy to you and very basic to you. Basically, we'll have Kubernetes sessions. There's basic Docker and Kubernetes, and there's intermediate Kubernetes where we'll be going in detail on all use cases, including starting from simple pods to more complicated and more advanced use cases. We also have advanced sessions for sort of edge cases. But this is just a brief example here where you can see the kind of resource. This is YAML syntax. The kind of resource we're requesting is persistent volume claim. So this is a PVC. This is basically users request PVCs, and PVCs are when I is the user's way of requesting persistent storage. So you can see in the metadata, I specify the name I'm naming my PVC. So each PVC in my namespace needs to have its own name, and this is where I name it. So my dash PVC in this example. And I can also in metadata, I can add namespace. So I can specify which namespace I'm adding it in. And in specifications, I have the different specifications, access mode. So read write once, for example, because I'm using block storage and I'm requesting 10 gigabytes of store of block storage. And of course, all of these, there's plenty of examples in our documentation. So you don't have to memorize anything or like know every single line and how what it does. For example, you just know so API version, for example, you'll see in our documentation what API version to use and so on and so forth. You don't have to specify anything. So this, when I apply this with kubectl, and we're going to show you how to do that in the Kubernetes session, this requests 10 gigabytes of block storage from me. Now in this one right here, I can use that block storage mounted to a specific path in my container by requesting a pod. So kind pod, also I'm calling it PVC demo pod, namespace, for example, my-research-group. And you can see spec containers. You can see it says containers. This is like if I had to put a percentage on it, more than 90% of the cases, you see one container per pod. But technically, you can have more than one container per pod sharing resources. But for the sake of simplicity, let's say we have one container, we're naming our container. So the pod has a name and the container inside of it has a name. And the image, this is the Docker image. So if I specify just BusyBox, this defaults to Docker Hub and pulls it from Docker Hub. But I can pull the image from our GitLab registries. I can pull it from Docker Hub from a different registry. Even if it's a private registry, there are ways to authenticate, and we'll get to that in later sessions. And the command that runs in my container when it starts is sleep the 3600, so sleep for 3600 seconds, so sleep for an hour. And volume mounts, I'm telling it to mount the volume my storage at /data. So this is the data directory where this volume called my storage will be mounted. And my storage is an arbitrary name that I specify in volumes. So volume mounts, I'm mounting my storage. Volume, I'm starting a volume called my storage for my pod. And of course, that my storage, this is an arbitrary. So I can call this XYZ as long as it's consistent here and here, and it's using persistent volume claim with the claim name my PVC, which is this one. So if I call this XYZ, I have to use XYZ here. That's just a brief example on how to provision pods and persistent storage in NRP. One quick thing to mention as well is that NRP hosts LLMs. So those are NRP managed LLMs that are publicly accessible to NRP users, and more on that is in our documentation, and we'll get to how to use those LLMs and how to get to agentic tools and code with the NRP's LLMs as well in a special session on agentic AI coding and vibe coding basically. But we host also different platforms like LibreChat and anything LLM. Those are basically chatbot like uh, chat GPT like interfaces where you can talk to the LLMs in a web service, so a web link where you can visit it like ChatGPT, for example, and you can talk to them. You can uh, ask them to questions from our documentation. You can upload docs and ask from docs and so on and so forth. And just like we mentioned, these are the three main ways to access the cluster, but to be able to access any of these services, you need to be part of a namespace or a group. So this is a good place to stop the session here. And the next session will be going over the NRP user portal and how to, if you're a namespace admin, how to add users. If you're a user, how to see your namespaces, how to access your namespaces. It's more relevant to namespace admins because we'll also be showing parts on how to add users, remove users, promote, demote, create namespaces, create groups, what's the difference between a namespace and a group, and so on and so forth. So I'm just gonna stop here, and to be able to follow the next session, you need to be part of a namespace or a group. So I'm just gonna stop here, stop sharing. And okay, we stopped sharing, and I'm gonna